So this is a satellite that is moving around the Earth. Let us say there is a man inside the satellite. Now, this particular astronaut is experiencing a force due to gravity that is pointed towards the center of the Earth. That force is going to be equal to G, M, capital M, which is the mass of the Earth, small m, which is the mass of the astronaut, upon r square. Now, r happens to be the distance from the center of Earth to the location of the astronaut. So basically, r is this distance from center of Earth to the location of the astronaut. So this is the force that the astronaut is experiencing, that is pointing towards the center of the Earth. Also, if we analyze all the forces on the astronaut with respect to being inside the satellite, then we'll have to apply a pseudo force that is in the opposite direction. That pseudo force will be equal to mv square divided by r, where v is the orbital velocity of the astronaut. We know that the orbital velocity of the astronaut is under root gm upon r. And if we do substitute this in this particular equation, we get the centrifugal force or the away throwing force to be equal to m into gm upon r whole divided by r. So we get g mm upon r. So according to the astronaut, when he looks at himself, or according to anybody in the space station who looks at the astronaut appears to be stationary to them. The astronaut appears stationary because there is an away going centrifugal force, which is mvo square by r, which comes out to be g mm upon r in magnitude, capital M being the mass of the Earth and small m being the mass of the astronaut. And the force that is towards the center of the Earth is, okay, so this is r, so this is r square actually, okay. So the force that is towards the center of the Earth is g mm upon r square, that is according to Newton's law of gravitation. So the away going force is matching the force that is towards the center of the Earth. So this is g mm upon r whole divided by r, so that will give us g mm upon r square. So this force is matching this force. That is the reason why the astronaut inside the satellite, when viewed from the point of view of anybody that is inside the satellite, or from the reference frame of the satellite that is orbiting the Earth, is stationary and is experiencing a net zero force. So when such a case happens, or when such a situation happens, we say that this particular astronaut is experiencing the phenomena of weightlessness. Because there is no net force on this particular astronaut. So basically, astronaut can float inside the space station because of this phenomenon of weightlessness.